you know? Okay, so here we go. We're recording now. Very good. If there aren't any other comments with regard to Lab 7, then we'll move into the PowerPoint. I believe everyone should be seeing that on their screen. Let me check my other monitor, make sure that that's what I have. Yeah, okay, so we are looking good. So here we go. All right. In this chapter, we're going to be talking about such things as configuring our layer 2 protocols and verifying their operation. Also, the Cisco Discovery Protocol, which we did discuss last week. The LLDP, which is very similar to the Cisco Discovery Protocol. It does a similar function in terms of its ability to discover other devices that are within the network and used for documenting the layout of our network. We'll also talk about DNS and how to troubleshoot it, configuring DHCP along with not only the DHCP router, but also using what's called as a DHCP Relay, and we did already talk about both of these. We'll be getting into TFTP, as well as DNS and our gateway options. TFTP, if you all recall, is your trivial file transfer protocol. It is very similar to FTP. However, unlike FTP, it is not secure or it's not reliable. It uses UDP rather than TCP for communications. We'll also talk about how to go about troubleshooting our DHCP and configuring our network time protocol. All right, excuse me. We'll move on to configure and verify device monitoring using syslog, which is a protocol for simply gathering statistics about devices within your network, and how to configure and verify your device management. Finally, talk about backing up device configurations. And then talking a little bit about the difference between CDP and LLDP. Finally, we'll take a look at such things as logging, time zone, and loopback. All right. So, first thing I want to talk about is a little bit about the different types of memory that we have in both our routers and our switches. And the first type is a read-only type memory, which exists in your router. And it essentially contains a bootstrap. And a bootstrap is nothing more than a very simple program that starts to initialize the system. And the first thing that it does is it goes to what is called the power on self-test, or the post. And during this, we are testing the circuitry. We're making sure that all of the basic components of the device, whether it's a switch or router, is reporting normally. Next, after the post goes through its routine and it comes back with a positive result, we then move on to something called ROM monitor. Now, we've talked about ROM monitor, and that was the part of the early operating system that we used to configure the configuration register and allowed us to bypass the startup.config file. After we get ROM monitor up, we also have another option called a mini IOS. And the iOS is the operating system for your switch or router. And however, there is a smaller version which allows us to do some fundamental device checks and diagnostics. Once we get out of our read-only memory, the next step is RAM, or random access memory. And RAM is typically a volatile memory. In this case, it is volatile. And by that, we mean if we lose power, we will lose whatever is in RAM. Now, RAM is used to hold such things as data regarding the network, routing tables, ARP tables. The running config is held in RAM, and it will stay there so long as the router or switch is running. Once we turn that device off, that information is then gone. All right. Next, we got the read-only memory, and again, this goes back to the earlier components that we talked about, the bootstrap, post, and ROM monitor. Our flash memory. Flash memory is a type of memory in which the operating system, or what we refer to as the IOS, is stored on your switch or router. So once your switch and router is booted up and it goes through the post, and then it gets to the ROM monitor and so on, it then goes through and it starts loading the IOS from flash memory. Flash memory is a non-volatile memory in that if we lose power, whatever's in flash memory is still maintained. In addition, we also have something called NVRAM, which is also a type of non-volatile RAM, meaning that unlike normal RAM, which is lost in a power off situation, NVRAM is not lost. And the way they do this is this stuff is, I think it's battery up, although they may have switched it to another type of memory these days. In either case, if you turn the power off, whatever's in NVRAM is going to be still going to be there. One of the things that we store in NVRAM is your startup config file, okay? So when the router or switch starts up, it copies the startup config from NVRAM, moves that into random access memory, and then starts executing those commands. Then finally, the configuration register is a single memory location in which we store various configuration settings. Specifically, the configuration register consists of 16 bits. Each bit is a flag that determines the operation of a particular function. If you recall, we talked about the password reset where we modified the configuration register, and we were modifying a single bit within that register in order to bypass the startup config file. All right. Wrong keyboard. Okay. So here's a piece that you've all seen before, and this is how do you display your running configuration file. And again, the command is very simple. You want to be in the enable mode, and you want to do show running or show run or show running-config. Now, what command would you use if you were not in the enable mode? Let's say you are in the global configuration mode. Can you still show the running config, or do you need to do something different? Anybody in the classroom? Nope.
Config T.
Well, config T gets me into the global configuration mode, but we're already there, Shema, and I now want to run or do the show running config. What do I need to prefix it with? Do. Did I? Oh. All right, great. So anytime you're in the global configuration mode and you want to execute a privileged or enable mode command, just put the word do in front of it, okay? Just as a side question, if you have entered in a command and now you look and you want to negate that command, you want to cancel that command that you previously gave, What do you need to put in front of that command in order to negate it? Okay, Anthony, thank you. No. The answer is no. So if you were to say, go in and say, let's say you're configuring an interface and you want to configure address on that interface. So you might say IP address 192.168.10.1 space 255.255.255.0. And you didn't want that address, then you would go back and you would simply, you just hit your up arrow key, you recall the last command, edit the command, and go to the very front of the command and put the word no in front of it, and then press enter, and it then executes the command no IP address 192.168.10.1 with a 255.255.255.0. All right, very good. Copying the current configuration to NVRAM. So you've already done some of this. Who can tell me where is well, yeah, it already tells you that right there. The running config, as you can see, is stored in NVRAM. And how do you get the running config into NVRAM to begin with? Well, let me back up a step. Where is the running config normally stored? Where is the running config normally stored? Okay, so Nathan says RAM, okay? And Nathan, what do we need to know about that RAM? What's special about that RAM? Okay, volatile or non-volatile? Oh, yeah, you put it in there, okay? It's volatile, correct. So the running config is stored in RAM. If we lose power or if we reload the switch or the router, we will lose the contents of RAM and we will lose the running config. So one of the things that we want to do before we do a reload, cycle the power, what have you, we want to copy the running config into the startup config, which is actually stored in NVRAM, which is the non-volatile RAM. And the command to do that is simply copy space running or copy run space start. That's how you abbreviate that entire command. It then comes back and it wants to know, do you want to use the default destination file name? Specifically, the default destination file name would be startup-config. If you press enter, you've accepted the default. If not, you have the ability to enter in whatever name you wish. And you may not want to, let's say, overwrite the startup config. You may want to create a new copy because, let's say, you're doing an upgrade on this switch or router. All right. Another option that we have when trying to back up our running config is let's back it up to another device other than simply another piece of memory on the same device. When you do the previous copy command, you're copying your running config onto a different piece of memory in that same device. Now, if that device craps out and goes to hell, okay, you've lost it all. So one of the things that you might want to consider is copying your running config into another machine, all right? And in this case, that could be a TFTP server. And a TFTP server could almost be anything. It could be a workstation. It could be a server. Remember, however, that TFTP is unreliable. It lacks some of the security features that we would generally find in some of the other protocols. And it is really meant for small files. Do not use it for transferring like an iOS file. You better watch out because it just does not do well with large files and it will lose data on you. In either case, the easiest way to do this is to simply use the command copy, run, and then TFTP. And at that point, the switch or router will come up and it will ask you, okay, well, what is the IP address of your TFTP server? Okay, so you give it the IP address. And in this example, we're using 10.10.10.254. So there's some server out there with that address running the TFTP server application, and you're going to be copying this file out there. Again, it asks for a destination file name. Typically what it will do is it will take the host name of the switch or router, and it will append that to the word -config. Okay, and that will become the default destination file name. Again, you have the option to modify that if you wish. All right. Now, in the event that, let's say, the switch that we're running on that we just backed up, or that we backed up a couple of weeks ago, has a major hardware malfunction and that thing is down, it's got to be sent back for maintenance. In either case, we've got a replacement, the exact same model. We pull that switch out of storage, we install it into the rack. Then the thing that we want to do is we want to copy back the running config. Now, the running config is currently stored on our TFTP server. So we would use this command, copy space TFTP space running, and at which point it's then going to come up and say, okay, great, give me the IP address of the TFTP server, in this case 10.10.10.254, and what is the name of that configuration file. Now you'll notice that it's not asking for a default because it doesn't know what the original host name was. Eugene. No, it's reverse. Because in copy, okay, it goes to from, okay, or yeah, from to. From to is the format of the copy command. All right. Let's see. So this is another way that we can not only back up our running config, but have the opportunity to restore the running config to a new but similar device and quickly get ourselves back up and running. I keep for the wrong keyboard here. Okay. From time to time, you may want to erase the startup config file, okay? Can anyone imagine why we want to why we might want to erase the running config? Or, I'm sorry, the startup config. Why would we want to erase the startup config? First, someone tell me, where is the startup config stored? Where is it stored? NVRAM, very good. So, non-volatile RAM, which means startup config is stored in a place that is never going to be lost, almost never. So if you want to reset your router and you want to reinitialize it back to factory defaults, if you will, you can erase the startup config file. And again, this is a privileged mode command. Can be done in the global configuration mode, provided you put the word do in front of it. But the command is simply erase start, okay? Or if you wish, the long version, erase startup dash config. The next thing that you want to do is you want to then reboot the router or switch. And the way we do that is we use the command reload. The system will confirm that yes, you do want to reboot or reload the switch or router, and you respond yes or no, and off it goes, and it will reload. DHCP. Now we've talked a little bit already about DHCP, and as you all know, DHCP is short for Dynamic Host Configuration Protocol. The purpose of DHCP is to provide workstations that do not have statically assigned IP addresses and gateway addresses. It allows us to dynamically provide those devices with this information so that they can subsequently communicate on the network. The way we do this is the first thing we're going to do is we exclude any addresses in the DHCP pool that we wish to reserve for static addresses for devices such as our router's gateway interface or for the DNS server and so on. Often we might reserve addresses for servers. Okay, servers typically have static IP addresses, so you'd want to include those. Other devices that you might want to exclude would also include printers. Printers many times have static addresses. In either case, you're going to exclude those addresses that you do not want to hand out to the other dynamic devices. Once we've done that, we move on to creating what we call a pool. And what they're referring to is a pool of addresses from which the DHCP is going to pull and then assign to the DHCP clients. So for each LAN, we're going to select a unique name. In the past, for our labs, we've been using names such as Network A, Network B, Network C, what have you. From here, we're going to choose a network ID, and this is very important. We're not talking about our router's gateway address or IP interface address. We are specifying a network ID, okay? And the subnet mask for that DHCP pool. Many of you were using masks of a /26, okay? Because we started with a /24, you had to subnet it, and you ended up with a /26, which is a 255.255.255.192. After we've identified or we've determined the pool, our next step is to identify the default gateway address. And this is the address that is assigned to the router interface that is servicing that network that we're handing addresses out to. Okay, so it's a router interface address that you're giving here. Now, what happens is when a DHCP client, such as a PC or workstation, reaches out to the DHCP server, it is asking the DHCP server for an IP address, but it's also saying, hey, who is my default gateway? At which point the DHCP server takes a look at the default gateway setting and it sends that to the DHCP client. Also, in addition to the default gateway, we also have the DNS server, okay? And the DHCP can share the address of your DNS server as well. Now, DNS is, some of you will recall, is your domain name service, which allows us to convert fully qualified domain names into IP addresses. Okay? If you don't want to use default lease times, which is typically like 7 days, you need to set a lease time and you specify the number of days, hours, and even minutes. I think they have an example. Wrong keyboard. Okay, so here's an example. So we want to configure DHCP on a network whose network ID is 192.168.10.0 with a /24. We're not going to be subnetting this. We're going to use it exactly as we see it. The first thing that we want to do is take a look at your diagram up here. Okay, I've got a wireless. You see my mouse? No, you guys are not seeing my mouse. Well, that's kind of lame. All right, if you look at the diagram on the left, you'll notice that there's a sales wireless area. And what happens is as laptops and other portable devices log into the network, they're going to want an IP address. Now, in this particular case, a switch is being used as an IP address. You can use both switches and routers. I personally prefer routers simply because of things like the relay, the DHCP relay. In either case, if you look at our router, okay, our router's address is 22.168.10.1 on that interface. And they are excluding the address of 10.1 as well as 10.10. Now, do they tell us where 10.10 is being... 10.10 may be the VLAN address for switch 1. I can't tell from the information provided here. But in either case, they are excluding two addresses. Next, we go on to define the pool. Use command IP DHCP pool and then sales_wireless. From here, we have to identify or define the network ID as well as the subnet mask for that network ID. And if you recall, up above we said /24, so that's equivalent in dotted decimal format to a 255.255.255.0. Our default router, which is the router interface, okay? Again, if you look at the diagram on the left and you look at the router, the IP address on that interface, F00, is 192.168.10.1. And that is the line that you see here that says default router, okay? Oh, I know where. That's interesting. Let me see if I can pick up a pointer here. That'll help. Okay, good. So that's our default router right there. Next, we might want to define what our DNS server is. And in this example, we're using 4.4.4.4. And then finally, we identify the lease period that we're willing to give an IP address and other settings out. And in this case, we're saying 3 days, 12 hours, and 15 minutes. Yes, if you wanted to do it for 8 days, 8 hours, then 080. Yeah, there you go. Okay, that was a question from the classroom. Another feature that we have is something called DHCP Relay. Now, one of the things about DHCP is that for the most part, DHCP will not cross subnets. It will not go from one router interface to another unless you set this thing up called a DHCP relay. Let me explain further. In our prior example, we had the switch was handing out IP address or handing out DHCP. However, in this example, the DHCP server is going to be handling this. And it's only going to be giving out addresses for this network right here with admin, but it's also going to be handing out addresses over here for sales. But typically, DHCP will not go across this. Hold on one second, gang. Hello. Oh, Christ. All right, sorry about that, gang. Anyway, in any time that a router sees a DHCP broadcast, for the most part, unless it's the DHCP server itself, it will drop that broadcast. It does not transmit that broadcast across multiple networks. So in order for the DHCP server in this example to service the laptops that are over here, okay, this DHCP server must communicate through this router. And the only way this is going to happen is if we use an IP helper address command. Now, one of the things that confuses a lot of students is, where do I specify this? Remember that your DHCP server is on this network segment, which is 10.10.10.254. And then you have this network segment over here that we need to service, and it's 192.168.10.1. Well, our command is, we go into our router here and get into the global configuration. We specify interface 00. You see interface 00 right there, okay? And then we specify IP helper address. So if the router at the address up here of 192.168.10.1, if it receives a DHCP request from a client, such as a laptop or a phone, what have you, it will then forward that request through the network to the IP address of 10.10.10.254, which is our DHCP server over here. All right. Specify the address. Okay, Nathan, hold on. I'm not quite understanding. Would you use the IP helper address command on the router? Did I just answer your question, I think? Right, okay, all right. Sorry about that. All right, so you're good then? Are you guys in the classroom here looking at the comments as they... Okay, so you see what I'm basically referring to. You know where to look at the comments, right? Okay. Yes, very good. Sweet. All right. In this particular case, we're talking about something syslog, and as your networks become more sophisticated, not only are they difficult to diagram, okay, but also it becomes a problem to collect sometimes information about what's going on. One protocol called syslog allows us to gather information from other devices within the network and then submit that information to something called a syslog server. Now, a syslog server, all it does is it just logs these entries from these other devices. This information is then passed up to a management software, which allows you to kind of sift through all of these syslog entries. So let's say you're seeing that there is a potential problem with one of the network connections out in your network, and you can say, okay, well, show me all the log entry for this particular address or for this particular device, you know, a router or a switch, with the hopes of possibly identifying any possible problems that we might be having with that particular connection. To set all of this up, we simply state in our enable mode, you'll notice it's the enable mode, logging host, and we identify the syslog server, which is that other machine out there on the network, as 172.16.10.1, and also service, we specify that it's to use timestamps and log the date and time as well as the millisecond. Okay. Another important piece, especially when trying to track down problems, is the network time protocol. Now, going back to syslog, if you don't have accurate times on those syslog entries, sometimes if your devices are out of sync, they don't have the correct time, then it can be a little confusing as to where the problem is happening because you don't see the correct chronological sequence in which some of these log entries are occurring. So it's critically important that we have a consistent time that we use across all devices within our network. And the protocol that allows us to do this is the Network Time Protocol, or NTP. And again, what you're doing is you've got clients out there that are going to be looking to the NTP server for time. And generally what happens is the NTP server might be a workstation, it could be a server. In the server course, this would be a nice task for a nano server or a core server. And all it does is it goes out to a government site and it picks up what the current time is, okay? It then takes that time and it gives that time to any other device within our local network and makes sure that they are all using the same time across the board. By having the same time, now the chronology of various events that are happening in our syslog will make a hell of a lot more sense. By the way, for those of you who are logged in, make sure that remotely that you have your proper name under participants. If you do not see your name under participants, then I'm not going to see it when go to do attendance and can't give you credit. So if you haven't changed that already, please do so now. Okay. Any questions so far? How are we doing? Guys, we good in here? Okay, very good. What did I say about attendance? Make sure that on the Join Me participants list that I see your name in here. Okay. Let's see. I can't even share that.
I can see my name.
Yes, if you can see your name, then you're good. Let me check the bottom. It's typically at the bottom. For instance, I've got a viewer 18 in here, and I have no idea who viewer 18 is. Okay, so who viewer 18 is, they will not get credit for attendance on today's lecture. All right, going back. All right, I'm going to kind of skip over this because we've already talked quite a bit about CDP, or the Cisco Discovery Protocol. As we had mentioned before in a prior video, CDP allows us to collect information about devices that are directly connected to the device that we're on. In this particular case, you'll notice that we've got a router here in the center, and you'll see that the router is connected to a couple of other routers out there. And what happens is CDP is going to allow us to collect information on those devices. CDP, one of the problems with CDP is it's a proprietary protocol. It works only on Cisco. And while it's nice, if you have non-Cisco equipment, you're not going to get a complete picture as to what your network looks like. So in order to get around that problem, we have another protocol. And there's documented, and we don't even talk about it. Okay, well, they said in the outline that we're going to talk about it, so we don't. But what that is LLDP, and it is also a discovery protocol. But it is non-proprietary, so it can be used on both Cisco as well as non-Cisco devices. So if you find yourself in an environment like that, take a look. Configuration is relatively straightforward. Just Google it, and you'll get plenty of information on how to set that up. All right. Any questions on Chapter 7?
No.
Okay, very good. There you go. Anthony, what's that link? Is that for LLDP? Part of my screen is covered, so it's hard for me to tell. Well, I can't tell. It's a screenshot of what? A screenshot of what, gang? Oh, yes. Oh, I've got the participant list here, but I don't know who viewer 18 is. So again, if your name is not on the list, then you've got a problem. All right. If there are no questions on Chapter 7, let's jump over to Chapter 8. Like Chapter 7, Chapter 8 is a review. Okay, let me get back. Okay, and we'll kill this. One moment, gang. Okay. Is chapter 8, and it's not allowing me to get an option here. 1 second. There we go. I think that's it. Now let's go to play. All right. So chapter 8, the Cisco IOS. And iOS simply stands for Inter-Network Operating System. And the iOS runs on both the switches as well as your routers with modifications based on their particular roles. So in this chapter, we'll talk about configuring and verifying our device management, any kind of licensing, perform device maintenance. Also, we'll get into Cisco iOS upgrades, recovery. We'll take a look at such protocols as SCP, FTP, TFTP, which we already talked about, as well as something called MD5 Verify. We're going to be talking a lot about MD5 when we get into 245 next semester, but we'll take a quick look at it here. Also, we'll get into password recovery and configuration register. We did that a couple of weeks ago, so this is totally a review for you. And then finally, something called the Cisco File System Management. Okay? Just as we have files and folders and so on in Windows, we have a similar system that we can use and manipulate within our Cisco devices, regardless of whether they be a switch or they be a router. So again, we're just going through and we're showing some of the different types of components as well as memory within our Cisco. Here is a better diagram. Kind of breaks it out for you and shows it a little better. But it shows you the different components and where they're coming from. So post strap are coming from ROM. Then you've got the Cisco iOS, which is the operating system, and it can be loaded either from flash, which is its normal location, or it can literally be loaded from a TFTP server. I don't recommend loading it from a TFTP server simply because TFTP, as we've said before, is unreliable and it could be a little glitchy. So next, you've got your configuration files, as you can see on the, let me turn on my laser pointer. There we go. You've got your configurations over here on the right-hand side, and they are located either in NVRAM, non-volatile RAM, an FTP server, and I'm fine loading this thing from an TFTP server simply because of the small size of these configuration files. The iOS, on the other hand, is a rather large file, like any operating system file. So I'm leery of using TFTP for that purpose. And then finally, you can actually even load it through a console cable. All right, we had talked about the configuration register, and we talked about how we wanted to change the register from a 2102 to a 2142. Purpose of bypassing the start of config. Now, when you look at the configuration register and you break it down into binary, 2102, if you recall our rules before that every hex character, and those are hex characters, 2102 are hex characters, every hex character is equivalent to 4 binary digits. So over here, you see that we've got a 2, and then we've got 4 binary digits down below, 0010. That's a binary 2. Then we have 1, so we've got 111, or I'm sorry, 001. Then a 0, and you're going to have 4 zeros, and then finally the 2 again, 0010. If we change this to a 4, that means that, let's see, this, yeah, this is the bit that's going to get changed right here from a 0 to a 1, making it a 2142. All right. Now, just be aware that different routers and switches sometimes use different register numbers. But every one of these bits here, and there are 16 of them, allows us to set a different operational parameter within the switch or the router. Okay. Let's see. Do they have that? Yeah, they do. Here we go. Let's take a look at what some of these bits actually do. So in bits 0 through 3, you have a couple of codes. All right. Boot up to ROM monitor, boot the image from ROM, or in O2 through F specifies a default boot file name. Okay. So when we boot, we can, and that only showed for basically a couple of the locations, but when we boot, we have the option to actually boot from different locations. We can boot from flash, which is the default, FTP, MOP, okay, which is a type of server that was put out by DEC, and I don't think DEC is even out there anymore. You know, DEC was purchased by Compaq, and I don't think you can even find a DEC brand server these days. RCP, ROM, and TFTP. And again, I prefer to stay away from TFTP, especially for files this large. And down below, you see an example, boot system flash. So boot the system from flash memory, and here is the name of the file that we're going to be booting from, okay? This is for a Cisco router 2800, okay? And it's got advanced security on it, and it comes in the form of a bin file. Anybody know what a bin file is? Guys, what's a bin file? Okay. Yes, it's a binary file, which means it's an executable file, okay? It has probably been compiled or what have you. It may even be written in machine code for that matter, but it is a form of executable file. All right, so here is an example where we are copying from flash to our TFTP server. And when we do this, we are specifying the source file name and then the destination server address, the TFTP server. Now, in this particular case, what we are doing is we are taking the iOS on a brand new router, as an example, and we want to back up that file because that file is valuable. Okay, if you lose that file somehow, you're going to have to pay money to get that C2800 file back. Okay, just like you pay for any other operating system. Okay, you're going to pay for this one if you need to replace it. So in either case, what we're doing is we're going to back up our operating system file to another server. Okay, and then we'll be able to, in the event that there's a problem, we'll be able to restore it from that server back on to, in this case, let's say a router. Okay, and you can see, okay, how many bytes it copies. And so this looks to be like a 12 meg file, okay? A 12 meg file. So it's not small. It's a heck of a lot bigger than your configuration files, which are essentially text files. All right. In the event that we want to restore the iOS file because somehow we lost it on the router, or we even want to upgrade the iOS file with a new version, we can copy that file from a TFTP server, and again, using the command copy TFTP space flash. So you're saying you're going to copy something from the TFTP server into flash on your switcher router, and you then the protocol then wants to know what is the IP address of your TFTP server, in this case 1112, and then what is the source file name that you're copying from the server, and that's that C28.bin file. That's this big long right here. And again, we're copying it from TFTP at 1112 to flash, which again is a form of memory in our router. Okay. Okay, so in either case, system comes back. It may come back and say, hey, look, there's already a file out here with that name. Please confirm that you want us to overwrite it, which to confirm, you just press enter. And then it goes about the process of copying that file. Okay, Cisco licensing. Okay, just like everything else, this thing has a license. Prior to 15 code release, there were 8 significant software feature sets for each hardware router type. With 15, the packaging is now called a universal image, meaning all the features are available, but based on how you go through and you license it, will determine what features get turned on. So to use the features in the iOS software, you must unlock them using the software activation process. Okay. Also, there are 3 different technology packages available out there. And these are as follows. We've got a data, or which is provided through MPLS or ATM or some other kind of multi-protocol support. Unified communications, and these are kind of features that that we have in the routers. So if you're going to be running this router with voice over IP, then you want to look at the voice unified communications. If you're looking for security, then consider the Cisco iOS firewall, IPS, IPsec, 3DES, as well as VPN. And these are some of the things, we won't be talking about these specifically with respect to Cisco next semester in 245, but we will talk about what each one of these does. All right. A way to show how your router is currently licensed, and this is a good thing to get documented, is to use the show license UDI. Okay, and you can see the output from that command here. Again, this is an enable mode command. Right to use, originally called evaluation licenses. Right to use licenses are what we need when we want to update our iOS to load a new feature, but either we don't want to wait to get the license, or just want to test to see if this feature is what we really need. So Cisco does provide a license model that allows you to install the feature without the actual software, or I'm sorry, the licensing key. The right to use license works for 60 days before you need to install the permanent license. So in order to enable this, okay, you want to use license boot module command. And this is especially helpful if you're trying to do stuff in Packet Tracer and you want to turn on a particular module and what have you. All right, so some of the commands that we have for license would be license UDU, license, show license feature, and then show version. Questions? Questions? I thought it was UDI. I thought it's UDI, not UDU. Okay, Nathan, thank you. I think that's a typo. All right. Any other questions? All right. Unless there are folks out there who need help with Lab 7 and the CDP, I am going to end this recording, and I wish all of you a nice weekend. Lab 8 will be coming out shortly, and it's going to be talking about some of the elements that we've seen in these 2 chapters, along with a couple of new things. Okay? All right, gang. Have a great weekend, and thanks for coming in. Okay? Take care. Bye. All right, guys. Thank you.